Okay, let's look at one more example here, finding the inverse of a function. So we have a square root function, square root of 2x minus 3. We're going to find that inverse, and then I also want you just to graph it on your calculator. I'll graph it on mine and show you what it looks like. But compare those two graphs. Remember that visually, we should see a function and its inverse are reflected, or they're symmetric about the line y equals x. That's just a good visual check for us. So let's go ahead and work on this thing. So replace f of x with a y. So again, all I did there was rewrite my original function. And now switch x and y. And we want to solve for y. So how are we going to get rid of the square root? Well, we're going to square both sides. So x squared, now that radical would be gone on the right side. Let's add 3 over to the other side. So x squared plus 3 equals 2y. Now to get y by itself, we're just going to divide that 2 by both sides. So y equals x squared plus 3 over 2. Now, is that the inverse function? We just did the math, right? We followed the steps. But if you graph this, x squared, that's a parabola. Well, that's not a one-to-one function, so that can't be an inverse of this function because this is not one-to-one. So I want you to stop and think about that. Big idea. Remember, the domain of a function becomes the range of its inverse. The range of a function becomes the domain of its inverse. So if we graphed this little square root function, well, what's its range? Well, it is 0 to infinity if you go look at it. 0 is the smallest it can be, and it goes up. It gets bigger and bigger. It's not a real great infinity symbol there. It gets bigger and bigger. Well, the reason I focused on the range is because that becomes the domain of this. And so for this one, we could say this is the inverse as long as x is greater than or equal to 0. So a parabola doesn't have an inverse, but half a parabola does. Visually, let's go look at that. So here's my calculator. And I've already typed these in. So here's our original function, our square root function. Here's our parabola, right? We came up with the inverse. And I'm also doing the line y equals x just to kind of cut this in half and visualize what's going on there. So let's go graph it. So here is our original function. It's blue. I'm not sure if you can see that or not, the color. There's our parabola, that red one. Notice that parabola can't be an inverse because it's not one-to-one. However, if I cut it in half, I'll just cover up half of it there. Notice everything that's greater than or equal to 0. Oh, that is an inverse. And there's my line y equals x. So visually we can see how those are reflected. So that's the key. So some functions, a lot of functions, right? If they're not one-to-one, they don't have an inverse, but we can limit the domain. We can specify the domain and force them to have an inverse. And we'll get a lot more into that in trig if you go on and take trig one day, working with sines and cosines, tangents, things like that. That's how we can force those to have inverses, which helps us solve a bunch of different functions. Alrighty.